is Carly McAvoy, and I'm teaching lesson 11 today for the ABE 064 class. Today we're talking about fractions and decimals. When you go into Math 90, you'll do a lot with decimals and fractions, but in this class I just want you to get a sense of what they are and just a little bit of vocabulary to go with them, and then not too heavy into it, but I would like you to be able to have a sense of understanding of fractions in case you don't have one already. Let's say I have the fraction 3/7. I read it as 3/7, and the number 3, that's called the numerator. And 7 is the denominator. The denominator tells you the total parts that you're talking about. And the numerator tells you the parts that you're looking at. So let's say I had a thing here, and I'm going to ask you to imagine that all these boxes are the same size. And I have 1, 2, 3, 4, 5, 6, 7 boxes. That's my denominator. Total boxes, 7. My numerator would be the part that I have that I'm looking at in particular. Maybe I shade this box, and this box, and this box. And then I would say, what's the fraction that describes my picture? Well, my picture, I've got 3 shaded parts out of 7 total parts. So the fraction would be 3/7. That would show that picture, describe that picture. Let's say that I had this picture, and I ask you to tell me the fraction that's described by that picture. Well, first thing is you can look at how many total parts you have. You've got 1, 2, 3, 4 total parts. So that's your denominator. And then how many parts are shaded? Well, you've got 2 that are shaded. So that would be that. Let's say that I have this. Those are all equal boxes still. Stay with me. If I have this picture, how would I describe that picture? Well, I have 2, 4, 6, 8 boxes. I don't know why that little thing came up, but so we have 8 total parts. And then the ones that are shaded, 1, 2, 3, 4, 5, 6, 7, so that looks like 7/8. That fraction, box, that picture, we represented by 7/8, 7 shaded out of 8 total. So you're going to be asked to label the numerator and denominator on your practice worksheet, which you should have printed and had with you as you do the assignment, or as you watch the video. And then you're going to be asked to say the name of the fraction given by the picture. So we just did a couple of those, so you should be ready for that. Let me give you one more. We don't shade this jibby jobby. We don't shade this one, we don't shade that one. Okay, so I have this picture. I've got how many parts total? 6. And how many parts are shaded? 2. So that would be 2, 6 represented there because 2 parts shaded out of 6 total. Okay, any questions about that? Ask your instructor if you don't understand what we're doing there. Remember, you have this video to help you, but you always have your instructor also. You can go into class and say, I saw this on the video and it didn't make any sense to me, and then they'll help you with that. Because that's what their job is all about. The next thing you're going to be asked to do Let me just show you the worksheet that I'm thinking about. You're going to label your numerator and denominator. You're going to name your fractions. And then the next part says decide whether the fraction is less than 1/2 or more than 1/2. So let's look at how to do that. I don't want you to do a lot of calculations here. I want you just to be thinking about it in your head. Let's look at a fraction that's exactly 1/2. Let's say I have 20 as a denominator. That means I have 20 parts. What would be exactly half of that? Half of 20, you would take 20 and divide it by 2. And so half of that would be 10. That would be exactly 1/2. So things that are less than 1/2 would be fractions like 1/20, 2/20, 3/20, and all the way up to 9/20. All of those would be less than 1/2 because the number on the top is less than 10. 10 is exactly 1/2 less than. And so 1 through 9, all those would be less than 1/2. Then the ones that would be more than 1/2 would be 11/20, 12/20, 13/20. Saw that I didn't say the right thing here. And all the way up to 20/20. That's more than 1/2. So really you want to look at, well, what would be the midpoint? And then to decide whether it's more than 1/2 or less than 1/2, you would write your exactly 1/2 point and then see if your number is on the left or the right of that. Let's try another one. Let's try 7/18. Question is more or less than 1/2? Well, what would exactly half of 18 be? 18 divided by 2 would be 9, so exactly half would be 9/18. 7 is less than 9, so I'm going to say 9/18 is equal to exactly 1/2. So 7/18 is less than 1/2, and remember the less than points to the left. 7/8 is less than 1/2. 7/18, sorry. What about 15/18? Well, 15 is definitely more than 9, so 15/18 is greater than 1/2. So we can have a fraction that's less than 1/2, equal to 1/2, or greater than 1/2. Let's do a little bit harder one. Let's say I have 3/15. The reason that's harder is because halfway to 15 is not exact, right? To 15 divided by 2, you'd have 7 with a remainder. So it's 7.5 is actually halfway. So half would look like 7.5, right? So that makes it a little, because it's not an exact even number, so what makes it harder. But definitely 3 is less than 7.5. So we were going to say that 3/15 is definitely less than 1/2. What's a 15th that would be greater than 1/2? Well, anything greater than 7.5, even 8/15 would be greater than 1/2. So how I want you to decide is to cut your denominator in half and then look at your number and say, is it less than that or greater than that? What about 14/19? Less than 1/2 or greater than 1/2? Well, what is half of 19? Half of 19 is 9.5. 9 with a remainder, so 9 and some more. So, and again, you don't have to be able to do that in your head. If you don't know what half of 19 is, do this. Write it down. 2 goes into 1, not at all. 2 goes into 19 9 times. You get a remainder of 1, so that's where we get our fractional remainder and get 9.5. So 14 is definitely more than 9.5. So 14/19 is greater than 1/2. So that's what I want you to do on that problem, is look at your halfway point and then decide if your numerator is less than or greater than the halfway point. And that's what we're looking for you to say. You could also be asked, is the fraction, I'm just going to call the fraction it, is it closer to 0 or 1/2? Is it closer to 0 or 1/2? So let's take 1/4. Let's not take 1/4 because that's exactly between the two. We want one that's a little more obvious. Okay, let's take 3/20. What is 0? Well, 0 is 0/20. All the way over here, total, if you had all the parts, you'd have 20 out of 20. And in the middle, halfway in there, would be 10 out of 20. So what we're asking is 3/20 closer to 0 out of 20, or is it closer to 10 out of 20? And halfway between here would be half of 10, which would be 5 out of 20. That's halfway between those two. And 3/20 is definitely over here. So 3/20 is closer to 0. Doesn't equal 0. We're just trying to get you to get a sense of where is a fraction. How big is a fraction? Is it pretty close to 0? Is it pretty close to 1? 1 is 20 out of 20 because 20 divided by 20 would be 1, right? Is it closer to 1? Is it closer to 0? Is it closer to 1/2? Those are the questions that we're asking you to figure out. And I want to make sure, I may have to rewrite this a little bit. I want to make sure the ones I chose were actually obviously closer or further away. Let's look at 4/10. Maybe you can answer that one on your own. 4/10. Well, I know that 0 would be 0/10, and 1 would be 10/10. What would half be then? Half of 10, which is 5/10. And so our number is 4/10, and that would be right next to this one. So it's definitely closer to 1/2 because it's closer to 5/10 than it is to 0/10. It's okay to write these spots up here like I did, and then you can see what's happening. This one's closer to 1/2. Okay? So we're asking you to look at the fractions and break them down to see what's the halfway point. Am I closer to 0? Am I closer to 5? 0 is the numerator is 0. 1, the numerator is the denominator. And then halfway is everything else in between. So we're looking for you to say, to make those choices, just, you know, it's not a calculation. It's looking at it and making some good choices that way. And I think the rest of those are going to be pretty good because all of these have denominators that are even numbers, so it makes it easier to break them in half. The other one, whether it's less than 1/2 or more than 1/2, there's some odd numbers in there, which makes it a little harder. So we want you to be able to label your fraction, to name a fraction you've given a picture, and to say whether a fraction is more than 1/2 or less than 1/2 based on looking at that halfway point. And we want you to be able to say if it's closer to 0 or 1/2, or maybe we would ask you, is it closer to 1/2 or 1? We could ask you on either side of that, and you should be able to do that. Okay, the next thing is about like fractions, and that's another vocabulary term that I want you to have. Like fractions have the same denominator. and subtracting like fractions is very easy. Adding and subtracting unlike fractions when the denominators are different, that's a lot harder. We're not doing any of the unlike, we're just doing like fractions today. So like fractions could be 1/7 and 4/7. Those are like fractions. They have the same denominator. The numerators could be different or the same. It doesn't matter, but the denominators have to be the same. I could have 1/12 and 11/12. Those are like fractions. I could have 5/9 and 4/9. Those are like fractions. Get the idea? All it is the denominators are the same. I can have 6, what have I not used here? 6/11 and 9/11. Those are like fractions because they have the same denominator. So what I want you to be able to do with like fractions is to either add them or subtract them. And as I said, that's not too hard. So let's say I'm going to add these two. All I do is add the numerators. 1 plus 4 is 5, and I keep the denominator the same. That's it. When you add like fractions or subtract like fractions, you keep the denominator the same, and you add the numerators or you add the denominators. Here, if I have this, keep the denominator the same, and then 1 plus 11 is 12. Okay. Down here, if I want to subtract, I'm going to keep the denominator the same, and I'm going to subtract my numerators. 5 minus 4 is 1. All this is saying is I have 5 of these and I take 4 away, what's left? Well, if you have 5 9s and you take 4 9s away, you've got 1 9 left. And the last one, if I add these, I've got 11s because that's what I'm dealing with, and I have 6 plus 9, which is 15 11s. Okay, so I want you to be able to add and subtract like fractions. I'm going to give you one more subtraction because we did 3 addition and only 1 subtraction, but it's the same process. So let's say I have 19/20 minus 14/20. As long as I have like fractions with the same denominator, I'm going to keep that denominator the same, and 19 minus 14 is going to be 5. So I get 5/20. So that's adding and subtracting like fractions. The harder thing is going to be deciding whether it's a half or greater. That's harder than adding or subtracting, really, when you're talking about like fractions. So this part shouldn't be too bad. The other part is the harder part, deciding whether it's more than 1/2 or less than 1/2 or closer to 0, closer to 1. That takes a little more thought. Adding and subtracting the like fractions that I put here, the denominators are the same. All you have to do is keep the denominator and change the numerators by adding or subtracting them. Okay, now we're going to go into decimal numbers. And again, with decimal numbers, we don't want too many things. We don't want you to have to do too many things, but we want you to be able to read them and write them. So that's what's on this assignment, is reading and writing decimal numbers. First of all, we need to give you some terminology. So let's do that. All of these after the decimal point have a name, just like the ones before the decimal have a name. This is the ones place, remember, and this is the tens place. And as we go to the right, when we have decimals, we say this is the tenths, TH on the end, tenths, and the hundredths, and the thousandths, it's thousands, but a TH added on the end makes it thousands, and the 10,000ths, and the millionths. Those are terminology that you're going to need in order to do this, to write and read that. So it's nice to have it written down. And as you try this, you don't have to just memorize it though. There's a definite relationship that's going to help you remember it. One thing is, when you have one decimal place passed, decimals and fractions are related. We can sometimes call them decimal fractions, okay? So it's related, it's a part of a whole, that's all that is. So when I have, let's say, 0.7, the way I would read that would be 7 tenths. 7 tenths. But as a fraction, 7 tenths, if you just said it in your head, 7 tenths, you would think 7 tenths. That's read the same way. Notice that when I have the decimal 7 tenths, I have one decimal place. When I have the fraction 7 tenths, I have 1 0. That's directly related. That always happens that way, which is nice. So let's say I have 0.42. And you know that's 42 cents. If you were out in the world and somebody said it was $1.42, you wouldn't be saying, what, 42? What are you talking about? Because we deal with money all the time. And there's 100 pennies in a dollar, so it's the hundredths. So two places you can remember because we deal with the hundredths so much. So this would be 42. And then you say what place you end in. We end in this second place right here, and so we say 42 hundredths. But what if you were going to say that as a fraction? 42 hundredths, what does that look like? Well, it looks like 42 hundredths. Notice 2 decimal places, 2 zeros. So that's the direct correlation. The number of decimal places tells you the number of zeros. So, what if you have something like this? 8.06. Well now, the 8 is a whole number, and I just say that like normal, so that would be 8. When you see the decimal point, you're translating that into words, you use the word and. So 8 and. And then you have 6. 6 what? Well, you look to where the last digit ended. It ended in the second place. And the second place is hundredths, so it's 6 hundredths. 6 hundredths. What does 8 and 6 hundredths looks like as a fraction? Well, it looks like 8 because 8 is still there. 6 hundredths looks like 6 over 100. 8 and 6 hundredths as a fraction looks like that. As a decimal, it's read that way. But both of those would be read the same, 8 and 6 hundredths, whether it's a decimal or a fraction that follows. What if I had 12.001 and ask you to write that in standard notation? In written notation, excuse me. The standard notation is the 12.001. How do you read it? Well, it's 12 and 1. And then you ask yourself, where did I end? You ended in that third place out. And the third place back from the decimal is thousandths. So that would be 12 and 1 thousandths. How would you say that as a fraction? Well, it'd still be 12, because 12 is a whole number, whether it's followed by a decimal or a fraction, it doesn't care. And then 1,000th. Well, 1 out of 1,000. And notice that there were 3 decimal places up here and there are 3 zeros when we change it into a fraction. That's how that always works. The number of decimal places translates into that many fractions. Of course, sometimes when you're going from a decimal to a fraction, you don't have to do it that way because maybe you've had some experience in your life with fractions to where you can do it automatically. Maybe you don't even realize that you can do it. But if I told you that you had 0.50 or 50 cents, what fraction would that be? 50 cents is half a dollar, right? So that's one that you probably already knew. What about if I told you you had a quarter? How many cents is that? You know what a quarter is. You deal with them all the time in your pocket. That's 25 cents or 0.25, right? So you know a quarter, you know a half. You probably know what 75 cents is off the top of your head too, because that's going to be 3/4, right? So that's just money. We do it so much that we call those benchmark fractions, your fractions that you talk about all the time. There's other fractions that you may be able to do very quickly in your head. Let's say I had a tenth. What does a tenth look like? Looks like 0.1, right? 1/10. The tenth is the first decimal place. 1/10 is 0.1. What about 7/10? Well, 7/10 is 0.7. All you have to do for the tenths is put that into decimal form that easily. 9/10. 9/10 is, you got it, 0.9. That's how the tenths work. 5/10 is 0.5. So you can go back and forth between tenths and the numbers pretty easily. Some that maybe you don't know as easily but are kind of nice to know are the fifths. 1/5, 2/5, 3/5, 4/5. 5/5 is 1. Any fraction where the numerator and the denominator are the same, those are always 1. But these are kind of nice to know. 1/5 is 0.2, 0.4, 0.6, 0.8. You can see the pattern 2, 4, 6, 8. So the fifths just go 2, 4, 6, 8. And those are kind of nice to know. If you don't know them, that's fine. It's no big deal. But do want you to kind of know these and the tenths, because the tenths are so easy to go back and forth. So I want you to be able to read a decimal and write it in correct notation. You read it just like you would a whole number, and then the last thing you do is you say what number it ended in. So for the last thing on this screen, I'm going to read that decimal that I wrote up there and write it in correct notation. You can try that on your own and then jump back in and see if you got it right. Definitely 34. And, because the and is the decimal point. And now I just forget about the decimal for a second, and I write this problem, the numbers from the decimal point over to the right, I write that like I would any other whole number. And so that's 75,000. $896. And then I do the last thing, and that is I decide where was my last number. If I look all the way to the right, what place did I fall into? Well, it was in the millions, so I say millions. Always at the end, I tell my readers where my last number fell. They also can tell by the word and, this separator. And so everything before that, that's whole number part. And everything after that, these words, those show my decimal part. And the word and separates them, but I always end. And the last word that I put up there is where my last digit was. My last digit was in the millions. So this would be read 34 and 75,896 millionths. That's how you would read this one. Read the whole number part, then the word and then you take care of the decimal part. And the decimal part is read just as you would a whole number, but the last digit tells you, okay, here's where my number ended. It ended in the millions place. Actually, it's a lot quicker to clear the screen using this, so I'm going to do that. Let's say that I gave you this 1 and 35 hundredths. And I ask you to write that in decimal notation. Well, one thing I want you to be able to do very quickly is realize the and is the decimal point. The 1 on the left, that's pretty easy, right? That's just 1. The 35 hundredths, well, here's what you want to do. If you're not good at memorization, then don't try to memorize it. But you know 100 looks like this. And if you write down 100 and you see the number of zeros, that's 2 zeros. So I would expect to have 2 decimal places. 2 zeros, 2 decimal places. And the number I'm going to write in there is 35. So 1 and 35 hundredths. That's how I would do that one. What if I had 2 and 5 millionths? A little trickier because millions has a lot of places in it. 2 and that part, boom, you're going to get that down right away. The second part, where you're writing the decimal part, that's going to be harder. What does millions look like? Well, a million looks like this. 6 zeros. So I'm going to write 6 decimal places. 1, 2, 3, 4, 5, 6. And what I know, because I know this is how this works, is the 5, when it tells me where the 5 ended, so the 5 was in the millions place. What do you think I put in all the rest of those spots? Zeros, because I didn't have anything besides a 5. It just happened to be that my 5 was sitting there in that million spot. That's why I had to put it in there, the 6th place over, because 6 zeros, 6 spots, and then everything else before that becomes 0. Okay, you try this one. Again, you should be trying all these and the ones on your practice sheet and then coming back and seeing how you did. 3 and 14 thousandths. Again, how you get good at these is to try them on your own. You don't get good at any math by just watching somebody else do it. 3 and 1,000. Well, I know 1,000 looks like this. And that has 3 zeros. So I know my answer has to have 3 decimal places. Now, how many decimal places does 14 take? Well, 14 is 1 4. So that just takes 2 spots, but I know that that's where it ended, was in the thousands. So it's got to be this. If I have gaps, I fill them in with a 0. All right? So what I want you to be able to do for this homework assignment is to read a decimal number, given a decimal number in standard notation, to write it out in written form, which we did before, or given something in written form, be able to write the standard notation. And they're not easy. And it's not a big part of what you're going to do to get, you'll work on this in Math 90 a lot more. But I want you to get a sense of it. And there's one question on your transition test that talks about this, either reading or writing a number, and I want you to have some experience with it so that you can recognize it if you see it, or when you see it. Okay, and then this is what I'm asking you to do. Write the decimal number in standard notation. You've got 5 and 23 hundredths, 12 and 7 ten thousandths, That should have a little space. And 8 and 406 thousandths. All right, so the 8 and 12 and 5 and, that's the easy part. And the rest of them you have to figure out where they go based on how many decimal places they have. On number 17, for instance, 10,000 has 4 decimal places. So you need to make sure you've got 4 decimal places in your answer. And then you have 3 where they're asking you to write them in written notation. 9.1, 7.06, 3.107. And so for that, you're just going to say 9 and then you have 1/10, 7 and 6 hundredths, right? That's what we're asking you to do. And the last thing on this is asking you to do some matching. And sometimes it's good test-taking skills. If you know some, match the ones you know. And then the ones you don't know, maybe there's just one left over and it'll be obvious. So let's say that you knew for sure, oh, 50 cents, I know that's, thought I could write on that. I know 50 cents is half, so 50 cents is a half, that's for sure. 25 cents, that's a quarter, so 1/4. 20% or 0.20, not really sure, but 75% I know is 3/4, so that's going to be 3/4. And I've already matched then 3/4 and 1/2 and 1/4, which means I have the 0.2 to match directly here. So that's what I want you to be able to do. There'll be at least 3 that you know. There may be one in there that you're not sure, but you should be able to match it then based on a process of elimination. But that's the last thing, is just matching some of those benchmark fractions to their equivalent decimals. And those are ones you know because 10 cents, 10 over, is a dime or whatever. So you know those a little bit there. Okay, that's the end of today's lesson, and we will do a little bit more with decimals and fractions in lesson 12, and then we'll do a little review, and then you're ready to move on and try that transition test. So good luck, and we'll see you next time.